Greetings everyone, welcome back to part 2 lecture of 3D printing on our NPTEL topic Microsensors, Implantable Devices and Rodent Surgeries for Biomedical Applications. So let's quickly revisit what we have discussed in the previous lecture. So we have briefly discussed about the introduction of 3D printing. What is 3D printing? How it can be done, or like what all are the different ways we can do 3D printing, and generally what is an additive manufacturing process is. So we have discussed about the history of 3D printing, like Chuck Hull developed the first 3D printer in around 1986, and he developed the technology known as SLA, which is mostly used today also, and followed by that around end of 1980s new technologies like FDM and SLS have been developed, and like that we have generally discussed about history, a brief history of 3D printing. So we discussed about the subtractive manufacturing and additive manufacturing. So what is subtractive manufacturing? It is just removal of material from a large block of its own material, like it can be wood, it can be plastic, it can be even metals, and we will generally remove materials from a parent block of material, and then we will create what we need from it. So that's what subtractive manufacturing is. The removal of material can be by means of drilling or by milling. So then we go to like 3D printing, how a 3D printable model can be created. So there are different mechanisms. First, we can make a model from the scratch itself. We will be having a 3D print or 3D modeling softwares like SolidWorks, Solid Edge, Blender or anything like that, and then we will model our object on those kind of softwares. Then we will pass those softwares to our 3D printers, and then those 3D printers will like depending upon which kind of 3D printer we are using, it will manufacture or make that object, and then those objects will be sent for post processing machines or manual post processing. So we will be getting a finished object exactly like how we modeled it in our CAD softwares. So that's a general introduction of 3D printer or 3D printing. So now like what is a workflow we discussed, like we will be having different methods or different mechanisms to generate a 3D model. One is like of course 3D scanning. So if you already have a model with you, then you can just scan it with some of the 3D scanners which is commercially available in market, and then you can create a 3D model or exact replica of what you are seeing. Okay, that's one way. Other way, you can always rely on a CAD software to make it, or you will be having a photo scanning booth where the object will be placed and multiple images of the object will be taken at the same time, and then we will stitch those images to make a 3D object or 3D model of what is inside that booth. Okay, then we will send that files to a slicing software. Before slicing, we need to make those file as a STL file or a mesh file, so that slicing software can take those files and slice it, means split it into different layers, so it can send to our machine. I already discussed that slicing software will be machine dependent. So it can actually like this slicing software will work based on the which machine we are going to print on, and it will slice or it will prepare a program so that our particular machine will understand it, so it can print what our object is. So then we discuss different 3D modeling softwares, like we are having SolidWorks, which is like an industrial level 3D modeling softwares. Then we have Blender, which is of course free, and Fusion 360, which you can use for like free for students and all. So there are a ton of software which is available in internet, which can be used for both free and like a student's version, and which can used in online or which can used in offline. There are variety of software. So based on what we need, we can select what software to use. So now then we discussed almost 3 to 4 different types of 3D printing technology. One be fuse deposition modeling or FDM, which is widely used because we have a roller in it and roller of filament, basically wire kind of filament in it, and we will be pushing those filament to our extruder. Those extruder will heat up those filament or basically melt that filament and deposit on our print bed. Okay, and based on the like sliced file or the G code that we send to our computer, sent from our computer to the machine, this will deposit those melted filament on the print bed, and subsequently we will get a finished object out of this printer. Okay, this is very basic printer. Like there are advanced printers too, like metal FDM 3D printers too, but this is one of like cheapest available in the market. Okay, and there are printers, as I discussed, which can support multiple filaments, up to 10 filaments while printing, so 10 different colors you can get. And we discuss most important 3 different types of FDM 3D printers, which is actually, this one is what you call it as Cartesian printers, and this one is Delta 3D printers, and this one is Core XY 3D printers. We discussed its advantages and disadvantages in the previous lecture itself, so I am not going to go back again. And SLA printer, where we use resin as a raw material and we use UV laser as agent to cure it, so we can have a solid mass of object from that for a liquid photopolymer. And some different kind of machines, different kind of SLA 3D printers, which is we have industry printers, we have normal desktop printers, and most important thing is every SLA printers must have a post processing mechanism. It can be, you can use either an bucket full of IPA to wash it, and you can even use sunlight which is having UV light to cure it, but there are industry accepted mechanisms to get the proper mechanical properties out of that printed part. You need to use such like those kind of post processing machines itself, like you have washing stations, you have UV curing chambers and all. So it's all depend upon what we are looking for. If you need a proper mechanical properties of out of that resin, then we need to surely go with these kind of mechanisms. Then SLS, where we use powder as a base material, and then we use the laser light to cinder those powders, so we will be getting an solid mass out of that powder. So that also we discuss, and this mirror is used to deflect that laser to put all over the print bed, so we will be getting a solid like mass out of those powders. And these are some different kind of SLS 3D printers. Yeah, these also require post processing, like removing the excess powder material from the printers and all. So now we will move to new topic, different types of 3D printers, like which we haven't discussed in the previous lecture. So yeah, first we will check about what is laminated object manufacturing technique. So here we will be using a material roll. So like here we will be having a roll of material which is basically adhesive coated laminated sheets. Okay, so this roll of material is basically adhesive coated laminated sheet which we will put on our machines, and this will be given to the print bed through a feeder. Okay, so this feeder, you can basically call it as a conveyor system or something like that. So this feeder will push the laminated sheet to where we required our object to be printed. So once this laminated sheet is gone through the feeder, there will be a laser head. Okay, this laser head will cut those laminated sheets based on our requirement, like it will cut those laminated sheet exactly how that layer should be. So that all those information we will be already sending through the printer through the slicing software. So then once this laminated sheet is here, our printer will cut, or our laser system will cut those laminated sheet, and the sheet itself will be having an adhesive coating. So it will stick on to the already or placed object. So it will be printed on like it will be pasted through to the already placed objects. So like that it will be continuously this roller will be feeding paper to the printer, and it will be continuously like like forming new objects. Okay, and this laser, this head, this feeder will also be having an inkjet head, so it can spray different colors on that laminated sheet. So you will actually get a very good high definition color print out of this printer. Okay, then like what about support materials? So this paper itself will act as a support material, and once entire printing is done, you can just simply remove that remove this printed object from the base, or printed object from the print base, and then remove the support material, exactly like how we do in our FDM printer. Okay, and these are some kind of different kind of adhesive like laminated sheets that we can use in this kind of printers. So okay, then we will see some kind of like available laminated object manufacturing machines. These are two kind of like LOM 3D printers. You can see the rollers here, which will be like supplied to this print head or feeder. This will push the paper, and here you have the laser system which will cut the laminated sheets. So you will be having a like different layers of paper that will be stacked one over another to get a proper 3D model. Okay, and let me zoom in a little bit. You can see like LOM manufactured LOM printed object. You can see even the layer lines, and it's actually a truly colored object. You can get endless, you can get millions of color, like millions of colors in dynamic range in these kind of printers. So that's one of the most advantage of LOM manufacturing machines. Okay, let me zoom back, sorry. Okay, so now we go to binder jet printing. So what is binder jet printing? It is having the same powder bed as we discussed in our SLS printing. Okay, it's also having a powder bed, but what we discussed in SLS printing, it's having laser to sinter the powder to form a solid mass there. Okay, in SLS printer we are having laser source which will be focused on each area, so we will be having a solid mass. But instead of laser, binder jet uses adhesive binders or adhesive materials which will be sprayed over the powder bed to get a solid mass. Okay, so here you will be seeing like liquid binders which will be sprayed through the inkjet printed, because it will be sprayed through the print heads to the powder. Okay, so this thing will have the ability, so this print head will have the ability to move in X and Y direction. So this will move covering the entire area of the print entire area of the print bed, and this thing will deposit liquid binders over the print powdered base material, and this binders will like hold those powders together. Okay, so in turn forming a solid mass. And after each layer is printed, this exactly like in SLS printer, this build platform will be go down by one like around 100 micron or 50 micron. Then again there will be reserve powder. This reserve powder will be having a powder roller. This roller will again fill a very thin layer of powder over the already printed material. Okay, so that's how binder jet printing is worked. And these printers is also having like an option where there is no support is needed, because this powder itself will act as a support material. Okay, so that's one of the main advantages, and as well as this supports really fast printing. So unlike those laser sintering and all, this printer is having a really high speed, as well as it also support color printing. So that is the major advantage of binder jet printing. Okay, and there are variety of powders or variety of material which can be used in powder like binder jet printings. So these are listed side here, you can just go through it. So now you can see a commercially available binder jet printing here, and next to that picture itself you can see how the binder jetting process is. Okay, so this will give, I strongly believe that this will give a clear picture of how the printing is done. So you will be having really minute holes of like minute holes in micrometer levels in your print heads, and this is having an individual controllability, like each printhead is having individual controllability, and this will jet binders. That means it will eject your adhesive liquids into the powder. So okay, you can see that, and there are some holes which is not like open. That will control accordingly how we need our printer, or how we need our object to be created, or how we need that particular layer to be. Okay, that's how binder jetting process is. You can see a liquid stream, or that's basically adhesive liquid. Okay, so next one is polyjet printing. So in binder jet we see base powder material, and we will be spraying binders, spraying adhesive liquid over top of that powder material. So we will be getting a solid mass of object. We will be getting what we designed in our 3D modeling softwares. Okay, so in polyjet, how it's working is, it's having a jetting head, it's having a print head, and those print head will spray liquid photopolymer. Okay, we have seen what is photopolymer in SLA printer, where we have a resin tank and we used to store resin on that vat tank. Okay, here resin or photopolymer is actually stored inside the like jetting head, which is actually supplied through some of the resin reservoirs. So this will spray photopolymer to the print base, and immediately after spraying it will be cured by UV lamp. Okay, UV light. So these photopolymers are actually very much reactive towards UV light. So once they come in contact with UV light, this photopolymers immediately solidifies. So before like once when it is in the print head, it will be in the form of liquid, and once it come in contact with UV light, then it will immediately solidifies. Okay, so that's how polyjet printing works. So we will be having jetting head, and this jetting or this print head will spray photopolymers to a base or above the already printed layer, and once it touches that part, it will immediately cure or immediately solidify with the help of UV light, which is attached to the print head itself. And this print head is also having a 2-axis mobility in X and Y axis, and once like same as that of every printer, this is also having an Z axis which will lower by a certain level once every layer is printed. So this is how polyjet printing is work. So the advantage of polyjet printers are, it can produce really high quality prints, and that too in multiple colors. Okay, so since these photopolymers are mixed with ink that we see in our printers, normal 2D printers, it have a capacity to reproduce millions of colors. Okay, and this will be really high detail, like it will be really it will be very much impossible to see, or it will be very much difficult for us to see the layer lines. That's the major advantage of polyjet printing, which can be used in medical industry and all. So you can see some of the most common materials that we used in polyjet printing. Of course, rigid photopolymers and flexible resins. Flexible means once it's printed, you will be having a flexible material in your hand, and then transparent, and you can even print some biocompatible photopolymers. So once it's printed, you can just use in biomedical application. Okay, so that's how polyjet printing works. Now let's see some of the polyjet printers and some of its printed parts. So this is one of the commercially available printer, and here you can see a printer in live action. This is just a photo. So you can see a print head, and near to the print head itself you can see UV light. It's actually white light. This will just like denote us that UV lamp is on. So UV light is actually like harmful for us. So and it is very much difficult to see. It will be on that blue spectrum. Okay, so there will be white light to make us sure that UV lamp is on. It will just denote that UV light is on, and it's not safe to go near that. Okay, and in next picture you can see some of polyjet printers printed part. Okay, so you can see the details on those parts. It's very much accurate and it's very much detailed. Like you can let me just try to zoom in once again. I hope you can see those pictures. So see, you can see those bottles and everything, and you can see how much accurate or how much in detail a PolyJet printer can print part. It's basically used in biomedical application where a surgeon needs to have a real world look of how a patient's organs look like. Okay, and there are multiple other applications too. Just a second. Okay, now we go to digital light processing. Okay, digital light processing, in those kind of printers we will be having a UV LED. This LED is basically UV LEDs, and these LEDs will be pass through will be in a prism kind of chamber, and then on top of that LEDs we will be having an LCD screen. Okay, so basically these UV LEDs will act as a backlight to that LCD screen. Okay, so once this UV LED shine, you can only and if you are looking in front of that LCD screen, you can only see parts where there is no image on that LCD screen. I will explain you more about this thing in the coming slide, but just get a basic idea of this thing. Okay, and then you will be having a print head on below this print head. Every part will be printed, and once each layer is printed, then the print head will move up by a 50 micron or 100 micron depending upon what resolution you give, and then next subsequent layer will be printed beneath a already printed layer. So this is how DLP printers work. So I hope you understand this thing. It's little tricky. Okay, you will be having a LED, UV LED, and those UV LEDs are shined towards an LCD screen. Different types of resolution LCD screens are available nowadays. Even 12K resolution LCD screens are available on DLP printers, which will give you high detailed surface finish for the printed parts. Okay, so these LEDs are shined light to the LCD screen, and these LCD screen will be forming an image based on what that layer needs, and if there is an image, that image will be negative. Okay, that image will be negative image, and all other area will be other than the area where there are no images, LCD screen will allow light to pass through it. Because let's consider, consider this as LCD screen, and if I need to print a circle with a cylindrical object, then this will be the thing, and here LCD screen will be black, and it will only allow light to pass or light to escape through this region. So this will solidify the resin layer just above that vat. Okay, so here you can see one such DLP printer, and next to that you can see the actual process. So here a square is projected on that LCD screen, and you can see light is escaping through these areas. Okay, so light is escaping through these areas. So the printer will, or the LCD screen will allow light to escape through that area or only through that area, and something like this shape will be formed here in this vat. So just after that you can see an image of a jewelry, which is actually not a jewelry, it's actually a printed part, mostly by wax material. So you can place this kind of highly complicated design ring on a molding sand, and you can pour molten gold or silver or whatever you want, and then you can get a golden or a silver jewelry exactly like this. So this is the major use of these kind of DLP printers, because it's much cost efficient than those SLA printers. Okay, so this is the most advantage of DLP printers. So we have discussed different types of 3D printers, different printers that are working on different mechanisms, different technology. Now where are these printers exactly used? Okay, what are the applications of these kind of printers? So mostly these printers are used, mostly these 3D printers are used in prototyping and product development industries. Okay, for example, if we design something, and if we need to check whether it perform exactly same as what we have made, what we have like formulated through theories, we need to make that object in real world, right? So earlier we use some conventional process like CNC or lathe milling, which require a huge lot of time. So those process might take up to week to a month to make the object to us, or to till we receive that object. And even after we receive that object, if it's having any problems, because if it's having some kind of design changes or design modification, again these this much time is wasted. Okay, so that is not a viable option or viable like mechanism to produce something. Like now we have 3D printing in 3D printing and 3D printing technology. So if you need to make three different kind of things, three different set of models, you can do all in once. Like if as I said earlier, if we can like have three different varieties of same object, we can place that objects on our print bed, same print bed, and we will get all three version at the same time. Okay, so once we design after 2 hours, or if we start designing and if we are done with the model, then we can put it for printing, and depending upon the print size and print bed, which is actually depend on printer, we will be able to get within hours or even within a day. So that is the most advantage of prototyping industry. And as well as now 3D printers or 3D printed objects are so reliable that even for product development people have started using it. Okay, mainly not in mass production, but in case of any space organization, especially like ISRO and all, if they we have heard that they are using 3D printing technology to check whether this thing works well or something like that. So that's already implemented. And in medical application we will be having 3D printers to produce implants and prosthetics which are actually customized one. Like each individual require each kind of prosthetics or each kind of implants, right? We will discuss more in later. So that's also there. And art and design industry, like just before we see a ring which is made up of DLP printers. So like that really complicated and really which will require a lot of manpower investment, we can just design a CAD software and we can print it using a printer. Then you can make that jewelry within like with less effort. That's what like in jewelry industry 3D printing will do. And you can actually make shapes which are even impossible for humans, or which are impossible for even a well mastered man can do. So that's also an advantage of 3D printing in jewelry industry. Then we all have come with like come across different kind of sculptures when we are like in a social place and all those complicated scans or complicated systems, if we have a proper 3D, if we have a proper shape, we can 3D print within no time. I am talking about the small models. Of course the bigger models require time and effort. So I'm just like explaining these all things are also possible with 3D printer. And if you have a 3D printer in your home, and if you like some special objects, and if you know a 3D modeling which is relatively easy to study, and then you can design those model and print those things. Okay, so that's also an advantage of 3D printer. And nowadays, as I said, there are 3D printers which are really affordable for everyone. So we can always make something that we like. So we discuss a little bit about 3D printing in biomedical industries. As I discussed earlier, each prosthetics or each implant should be customized to each individuals, which is very difficult in conventional manufacturing process. So with 3D printer, you can manufacture something which will exactly fits to each individual, and which can even match their color tone and like their body sizes and everything. So that's a major advantage of 3D printing in biomedical industry. Even the prosthetics, different kind of prosthetic hands, legs can be 3D printed, or there will be implants that can be 3D printed and placed inside a human like body or something, which can be like of really lightweight and really like matching the size which that individual is required. So we have seen different kind of dental aligners. Okay, nowadays even doctors used to scan a patient's mouth with 3D scanners. There are very small 3D scanners available in market which can actually scan a patient's mouth with high precision and high details. So doctors or those technicians will get the 3D image of one's mouth, and then they can actually convert those 3D models or they can actually use those 3D models to make dental aligners or retainers. So you can see those things in this picture. So doctors can make those dental aligners exactly the same dimension where what an individual wants. So that's an like advantage of 3D printing in like in dental industry, as well as like nowadays like doctors used to 3D print organ, like 3D print an organ of like one's organ with the help of MRI scanning and all. You will get a 3D model, and with that 3D model we can 3D print or we can make a real model of one's organs, and that is used for the surgeons to like analyze what are procedures and to study what the exact condition is on, like they can actually plan a surgeries according to that thing, so it will be more efficient. So in surgeries and also all 3D printing is widely used nowadays. And then we can take a brief look at about some of the objects that we printed in our lab, which is used in various kind of projects. Here you can see a backpack and an electronic enclosure which will be attached to RAT for some kind of like recording and simulation related projects. So this backpack is actually flexible and this enclosure is rigid. So we are using two different kind of materials in order to get a product developed. This flexible backpack will be having some kind of hole, so rat can safely insert his leg to inside that backpack, and this will allows us to hold that electronic casing much more firmly onto the rat's body. Okay. So if we consider some kind of normal conventional manufacturing process, this will be a little bit difficult, but since we are having a 3D printing technology, we can easily manufacture something. We can easily design this backpack according to that rat's dimension, and then we can use it for a project. And you can see this enclosure, which is actually enclosing electronic modules and batteries inside it. It will be very much difficult for us to acquire this kind of small electronic casing in a ready-made store. So we need to 3D print it. If you are going with injection molding, then it will be cost in lakhs. So since we are having a 3D printer, we can 3D print those things exactly the dimension which is required by the PCB and battery, and lightest weight possible, so rat can hold it easily. So this is one project, and here you can see another bone simulation project which we use a 3D printed case for. Like this is actually for rabbit, and you can see how tight the PCBs are packed. So we can design something which will exactly needed only this much of space and which can hold those PCBs, and it's also having some kind of batteries inside it. So it can hold these things in a much confined space, so we can save space as well as we can make something really light in weight. So now we will be seeing some other object which is not like those two projects will only use 3D printing to make some casing or something. Here there are 3D printed parts which are functional in nature. So this is actually a medical auto injector. So what is auto injector? Auto injectors are a device which we use for like immediate drug delivery to a patient. Okay, there are insulin auto injector, there are epinephrine auto injector. This is a epinephrine auto injector which is used for the treatment of anaphylaxis, which is an emergency medication device. Okay, so this device will have all the components inside it, so it can emergency or it can immediately deliver the drug to a patient who is under anaphylactic reactions. This is a complex assembly inside. I think one of its part I have shown you in the previous lecture, and this is an headband which is having flexible and rigid material. So this headband is consisting of both materials, a flexible and a rigid material, and it's actually used for EEG acquisition. So this is having a rigid part here, and all others are flexible, so the user can wear it really comfortably, and we are able to get a really good skin to electrode contact from this headband. And this is another size adjustable headband with the rigid material only. This is also used for EEG acquisition, and this is an acquisition unit which as we said, we can model the device accordingly, so it will be having minimal interface or minimal noise from the outside. So that's how this thing is designed and developed, and this is actually FDM printed, while all others are SLA 3D printed. Like said, we can select between what we need to do, like what process we need to choose. If it's requiring only like a casing kind of things and doesn't require that much accuracy, we can always go with an FDM 3D printed parts. And if it requires really high details and high accuracy, then it's always better to choose SLA 3D printers or SLA printing technologies. So now, what are the limitations and challenges that we are currently facing in the 3D printing industry? Of course, even if we have this much huge variety of material, these materials are not enough to conquer or for all our needs. There are materials like which can't be used for low-end 3D printers, and if we need to use some kind of carbon fibers for a FDM 3D printer, then we need to invest a lot for the machine. And there are like certain kind of materials which are not able to be which we need really badly, but that are not available in 3D printing industry. So material is a major limitation in 3D printing industry, and design complexity. For example, if the size is very complex, then we must have some kind of support structure. So once we remove that support structure, we will be having support marks on those printed surface. Okay, then we need to do additional post processing to make it a product kind of thing. So that's one of the negative part in 3D printing with supports. There are printers which doesn't require any support, but of course that is more on the costly side. Then printing speed and size. Okay, like 3D printers, generally all 3D printers are very small in size, at least those which are available in desktop sizes and hobbyist level. If we go to industrial level, then it's another story. We will be having very huge 3D printers which can even print a part of a car in one go. But on the other hand, if almost all other 3D printers are very small in size, and even there are 3D printers which are having a print size of 500 by 500 in mm. If you print something, there are high chance of that part is getting not coming properly or something like that. So that is a major disadvantage in 3D printing, where you will be having a bigger size. There are chances that that part is not coming out properly. And then criminal activity. You might be thinking what criminal activity that we can do with 3D printing, but recently there are many news that people are making firearms with 3D printer. Okay, so if we have a 3D printer and if we have a gun model available with this, then we can easily 3D print one gun model and we can use for criminal activities. It's nothing like that. It's untraceable now with the technology that our government is having. It's very much easy to catch who are doing those kind of criminal stuff. But please don't indulge in such kind of criminal activities. I'm just saying these are the challenges in 3D printing. Even we heard a news that New York government has banned people from buying 3D printing, so they will only allow us to buy if our criminal records are clear. So then the future of 3D printing. As we discussed, the advance in material, material advancement is the major future in 3D printing. Means people are researching more about new materials, how they can develop new materials for different kind of 3D printing, as well as people are even researching on bioprinting. So in future you might be able to see a bioprinter where you can print your heart and you can place that heart or any kind of your organ, and you can transplant your malfunctioned organs with a printed part. Okay, so even the research are going on that, and researchers are even able to like successfully develop the living tissues with a 3D printer. So that's one thing. Here is just a demonstration of bioprinting. And then then the future advancement will be integrating 3D printers with other technologies. Okay, what are the other technologies? For example, if you need to have a casing, and that casing can be 3D printed, and you can automate that casing to enclose or keep each electronic components inside that. Okay, so you can even you can remove a PCB from that, so that you can make a casing really compact in size. So that's one kind of integration of other technology, and there are numerous other technology like automation, the printing and everything is there. And here you can see a 3D printed house. Okay, so there are even in India itself, there are so many houses which is there are so many teams who are working in 3D printing, construction based on 3D printing. So these uses robots to deposit concrete exactly like the FDM mechanism. So this robotic head can move its head, and it will deposit the concrete exactly how we need, and it will give a it can basically print a house or something from scratch. So that's a major advantage of 3D printing in construction areas and all. So how will it affect us, or how will it give advantage? That's a major question. So once we are 3D printing using 3D printing in a house, you can build an house really fastly, and if it's actually a big project, you can even save money on that. And you can see how complex the shape can be. There are many limitations when we manufacture something using the conventional methods. While using 3D printers, robot will take the job, and you can even make very complex shape using 3D printing technologies. In future, we might be able to see different kind of parametric modeled houses. Yeah, we can hope we can see it soon. So that's the end of this lecture. We can see in our live lab session, where we will be teaching you how to use a real 3D printer, how can we convert our ideas to real objects. That will be shown in the live lab section, and hope you all understand the lectures really well. If you have any queries, feel free to contact us through our NPTEL portal. We will be happy to assist you, and thank you. That's all.